Now, before we get to the combination formula, I want you to remember the permutation formula because they're very similar. The permutation formula allows you to determine the number of permutations or arrangements given a specific parameters. The notation P of n choose r means the number of possible permutations of n things taken r at a time, and the algebraic notation is P of n choose r equals n factorial divided by n minus r factorial. As a reminder, some calculators and some books use this notation or this notation, where we have the n and the r as subscripts, one before and one after, or both after with a comma between them. So similarly, we have a combination formula. So the combination formula uses the notation C of r n choose r and means the number of possible combinations of n things taken r at a time. The algebraic notation is C of n choose r equals n factorial over n minus r factorial times r factorial. So this extra r factorial in the denominator is getting rid of the repeats because the order doesn't matter. So that's why we have a new formula here. So we're going to go ahead and use the formula to find the following. Now you can use your formula or you can use your calculator, and I'll show you how to use both. For this first formula, we are trying to find the combination of 10 choose 6. So 10 is our n, goes in the numerator, divided by 10 minus 6 factorial times another 6 factorial. So when I'm working this, I have 10 times 9 times 8 times 7 times 6 factorial. I stop at 6 factorial because there's a 6 factorial in the denominator. And 10 minus 6 factorial is 4 factorial. So that gives me 10 times 9 times 8 times 7 times 6 factorial. On the denominator, 4 times 3 times 2 times 1 times 6 factorial. So the 6 factorials divide out nicely. And if you can find some other things that divide out nicely, like 4 times 2 is 8, so you can take the 8 in the numerator and the 4 times 2 in the denominator. That can divide out nicely. Additionally, you can take the 9 and the 3 and divide that out to 3. So we have 10 times 3 times 7, which is 210. So that is how you find C of 10 choose 6. Now you could also use your calculator if you wanted. Obviously you could use your factorial button if you had one of those. If you have a combination button, I'll show you how to use that. Mine is found on the probability menu. The second choice is the n choose r for the combination. So the way I'm going to do that in my calculator, because it's written in the NCR format, I'm going to put the n first, which is 10, choose from the probability menu and select the combination this time, and then 6, and that's going to get me the same 210. For our next example, we have the combination of 8 choose 7. So 8 is our n, and the denominator we have 8 minus 7 factorial times 7 factorial. So in the numerator I have 8 times 7 factorial. I also have 1 factorial, which turns out just to be 1, times 7 factorial. So the 7 factorials divide out nicely, and I just get 8 divided by 1, which is 8. Completing that in the calculator, I would type 8 from my probability menu, find the combination function, 8 choose 7, and the answer is still 8. For our last problem, it's much more complicated because we have a numerator and a denominator. So in the numerator we have 10 choose 3, so we have 10 factorial over 10 minus 3 factorial times 3 factorial. And then in the denominator I have the combination of 6 choose 4. So we have 6 factorial in the numerator, 6 minus 4 factorial in the denominator times another 4 factorial. So I'm going to have to work each of these. So in the numerator in purple I have 10 times 9 times 8 times 7 factorial. I stop at 7 because I know I have another 7 factorial in the denominator. And then this is over the blue. Now the blue I have 6 times 5 times 4 factorial divided by 2 factorial times 4 factorial. So in my purple, the 7 factorials divide out nicely. And I have in the purple 720 over 6. In the blue, I have the 4's dividing out nicely, and then I have 6 times 5, which is 30, and then 2 factorial is just 2. So now I can divide these nicely. 720 divided by 6 is 120 in purple, and 30 divided by 2 is 15. And so then I'm going to take 120 divided by 15 to get 8. So my final answer here is 8. And then if you had a calculator with a combination button on it, you could do this problem a lot more simply by just doing 10, use the probability function, choose the combination function, then hit divide, and then 6 combination 4, and hit enter, and you're still going to get the same answer, 8. Our next example, in the card game Go Fish, a person is dealt 5 cards from a standard 52 card deck. In the order in which the 5 cards received does not matter. How many different 5 card hands are possible? So because the order does not matter, this is telling me that this is a combination. I have N being 52 cards. I am choosing 5 cards out of that. So I have combination of 52, choose 5, which is 52 factorial over 52 minus 5 factorial times 5 factorial. And that's 52, 51, 50, 49, 48, 47 factorial. I stop at 47 factorial because I see there's one in the denominator. And then 5 factorial is 5 times 4 times 3 times 2 times 1. So now I can divide out the 47 factorials. And then I can try to divide some more things. 5 and 50, that's 1 and 10. 48 and 4 can be divided. That is 1 and 12. 2 can be divided by 52, and that's 26 and 1. And then 3 can be divided by 51, and that's 17 and 1. And that these are not this is just optional. You could get out your calculator and just multiply it all out if you really wanted to. I was just trying to avoid having a denominator. So I have 26 times 10 times 17 times 49 times 12. And that's going to get me 2,598,960 different ways you could get your 5 cards for your Go Fish game. Obviously, if you had a calculator with a combination button, you could do this a little bit easier by just typing 52, use your probability button to find the combination button, and 5, and you get the same exact answer. Our next example, you volunteer to pet sit for your friend who has 7 different animals. How many different pet combinations are possible if you are able to take 3 of her 7 pets? So we have N equaling 7, R equals 3, and does the order in which you take the pets into your home matter? I don't really think so. I think if the animals are coming in your house, it doesn't really matter if the dog came in first and then the cat came in. You're watching the animals. So because we're talking about watching your animals, this order does not matter. So I'm going to choose a combination of 7 from 3. So we have 7 factorial over 7 minus 3 factorial times 3 factorial. And then we have 7 times 6 times 5 times 4 factorial. I stop at 4 factorial because there's a 4 factorial in the denominator when I take 7 minus 3. The 4 factorials divide out nicely. 2 times 3 is 6, so the 6 and the 2 times 3 can divide out nicely, and I'm just getting 7 times 5. So there's 35 different ways that you might be able to take your friend's animals as your pet watching